Hello friends, the topic for today is Standard Machine Learning Task. A machine learning task is the type of prediction or inference being made based on the problem or question that is being asked and available data. For example, the classification task assigns data to categories and the clustering task groups the data according to similarity. Agenda for today's video: introduction, types of task, and standard machine learning task. Let us start with the introduction. Machine learning is a subfield of computer science that evolved from the study of pattern recognition and computational learning theory in artificial intelligence. Machine learning explores the construction and study of algorithms that can learn from and make predictions on data. Such algorithms operate by building a model, for example, inputs in order to make data-driven predictions or decisions rather than following strictly static program instructions. Then let us go to the types of tasks. Machine learning tasks are typically classified into four broad categories depending on the nature of learning signal or feedback available to a learning system. These are supervised learning, unsupervised learning, reinforcement learning, and semi-supervised learning. Then let us go to the supervised learning. The computer is presented with example inputs and their desired outputs given by a teacher, that is the supervisor, and the goal is to learn a general rule that maps inputs to outputs. Then let us go to the unsupervised learning. No labels are given to the learning algorithm, leaving it on its own to find structure in its input. Unsupervised learning can be a goal in itself, that is discovering hidden patterns in a data, or a means towards an end. Then let us go to the reinforcement learning. A computer program interacts with dynamic environment in which it must perform a certain goal without a teacher explicitly telling it whether it has come close to its goal or not. For example, driving a vehicle. Another example is learning to play a game by playing against an opponent. Then let us go to the semi-supervised learning. Between supervised and unsupervised learning is semi-supervised learning, where the teacher gives an incomplete training signal, that is a training set with some of the target's output missing. Then another categorization of machine learning task arises when one considers the desired output of a machine learned system. With this categorization, we call the task as standard machine learning task. Now let us go to the standard machine learning task. The following are some standard machine learning tasks that have been extensively studied. First is classification, then regression, ranking, then clustering, and dimensionality reduction. Then let us go to the classification. In classification, inputs are divided into two or more classes, and the learners must produce a model that assigns unseen inputs to one or more of these classes. This is typically tackled in a supervised way. So it's an example of supervised learning. This is a problem of assigning a category to each of them. For example, a document classification consists of assigning a category such as politics, business, sports, or weather to each document, while image classification consists of assigning to each image a category such as car, train, plane, etc. The number of categories in such tasks is often less than a few hundred, but it can be much larger in some difficult tasks and even unbounded, as in optical character recognition, text classification, or speech recognition. Spam filtering is an example of classification where the inputs are email messages and classes are spam or not spam. Then let us go to the regression. This is the problem of predicting a real value for each atom. In regression, that is also a supervised problem, the outputs are continuous rather than discrete. Examples of regression include prediction of stock values or that of variation of economic variables. In regression, the penalty for an incorrect prediction depends on the magnitude of the difference between the true and predicted values. In contrast with the classification problem, where there is typically no notion of closeness between the various categories. Then let us go to ranking. This is the problem of learning to order atoms according to some criteria. Web search, for example, returning web pages relevant to a search query, is a canonical ranking example. Many other similar ranking problems arise in the context of the design of information extraction or natural language processing system. Then let us go to the clustering. In clustering, a set of inputs is to be divided into groups. Unlike in classification, the groups are not known beforehand, making this typically an unsupervised task. This is the problem of partitioning a set of atoms into homogeneous subsets. Clustering is often used to analyze very large data sets. For example, in the context of social network analysis, clustering algorithms attempt to identify natural communities with large group of people. Then let us go to the dimensionality reduction or manifold learning. This problem consists of transforming an initial representation of atoms into a lower dimensional representation while preserving some properties of the initial representation. Dimensionality reduction simplifies inputs by mapping them into a lower dimensional space. Topic modeling is related problem where a program is given a list of human language documents and is tasked to find out which documents cover similar topics. Another common example involves pre-processing digital images in a computer vision task. The main practical objectives of machine learning consists of generating accurate predictions for unseen atoms and of designing efficient and robust algorithms to produce these predictions even for a large scale problems. So to do so, a number of algorithm and theoretical questions arise. Some fundamental questions include which concept families can actually be learned and under what conditions. Then how well can this concept be learned computationally? We'll try to find answers to these questions as we go along with the machine learning. With this, we come to the end of this video. If you like the video, press the like button, share with your friends and subscribe to our channel Engineering and Technology for You. And don't forget to press the bell icon so that you get notifications for future videos on this subject. And thanks for watching. Have a nice day.